wireframe. Now I'm going to try and convert an IGES model. So again, I start with nothing. There should be an IGES file here. There it would open demo. Okay, I will read this. Quit. It's a type 128 NURB service, and the rest is bookkeeping. Which names will these lines have after importing? There we go. There's a graphical user interface, of course. We open that just for recognition. These are the NURBS services, and I could have shown you that this is the model in Rhino. So it's, this is actually the same one, and you will get, well, you will see the similarity between the two. It's just literally the same geometry of things. However, this is only a wireframe. So we did not import a surface. We imported lines that together will constitute a solid model when I'm done. And what will that take? I can use the wireframe option to generate wireframe connections. First, I will increase the accuracies a bit. That's always a bit of fiddling, because even a NURB services or an IGES file exported from Rhino, from any other software, does have limited accuracy, always. And on reading it, we have our own setting to recognize or to find the connections between points, because as it is now, they are unconnected wires. If I do that, I press automatic, and here they are being recognized, inserting point at intersections. I have to fill up the time a bit, because it takes, well, on my machine it took a minute, and second part will be going quicker because less and less lines are remaining. If I press apply, it will basically do the same thing again to insert the point, not only recognize them, but build up the model to insert these intersection points between all the lines. So bear with me for a moment there, and then wireframe, convert the wireframe to solid. And that is a neat trick, because if you could do if this were easy, you could do it in AutoCAD, or you could do it in any other program, this automatic conversion. It takes a lot of calculations to find out which part of this model are actual surfaces in the shell of the model, in the outside of the hull. Because I can, any route from one point that would come back to its, to make a contour on the shell, could in theory be a shell part of the hull. Only you cannot come from this point to there without crossing this frame here. So we need to figure out the smallest loops in the model to figure out what is a plate and what is part of the shell plating and what is not. Well, ready to be converted, apply, there we go. Now it's a solid model, and I want to show you that. Detailed mesh 0.2. Let's do the stripe font, go all the way. Rotate stripes. This is the solid model. So that's a 2-minute conversion, basically. So this is one of the most perfect IGES files I've come across. Typically, they would consist of multiple patches, and the lines would not match, or the separation between different parts of the model would not match. We may have double lines or other entities not supposed to be part of the hull model. There may be text in there, there may be loose points, loose lines, etc. We've had models with 36 deck lines well, at the same location, and that would of course hamper automatic conversion of this. So as easy as it looks, it may not always be.